G'day, how's it going? Today we're going to be doing ProcNet from Hack the Box, which is another Sherlocks DFIR machine. And this one is rated hard, but it's on the easier side of hard. We do get to use some new tools to investigate Windows system API calls that have been made and logged as part of the forensics. And we also get to do some more familiar stuff with network packet captures in Wireshark and a little bit of Windows event logs. So without further ado, let's jump in and have a look at the scenario. So having a look at the scenario for this one, looks like this is a simulated attack this time instead of an actual breach. And our red team has simulated the attack using open source C2 frameworks, command and control frameworks. And they've done this because there's a rising use of those by threat actors in the wild. The interesting thing about this scenario is a focus on capturing API activity, and to clarify, the APIs being talked about here and being captured relate to Windows architecture and the APIs which programs and applications can call in order to interface with the system, kernel and hardware. So if we have a look at what forensic artifacts we've got, we have some dumps from the employee and the domain controller, and within each of these we have a sysmon event log, a network packet capture, a PCAP, and the APMX64, which is the API capture. And we have the same information from the domain controller. Now, we've looked at packet capture and event log analysis several times in the past, but we haven't had a look at API analysis. So let's start by having a look at this APMX64. There's some information here about the program that's intended to be used called API Moniter. So we can jump online. And it's the Rohitab API Monitor. And I downloaded the portable executable version of that, which I have here in my downloads. Okay, so it's a fairly straightforward interface. We've got some API filters, the monitored processes, summary of activity, and then some detailed information down the bottom. And we can just open up, we'll start with the employee. Let's recognize that file type. And we have three processes that have captures. So the first one here is CSGO, which is a little unusual because that's a Counter-Strike game, and I wouldn't expect to see that on a work computer. We've also got notepad and net.exe. Net could be just legitimate administration activities, but it can also be used by malicious actors for enumeration, and particularly looking at users and groups on the domain. So let's start by having a look at the CSGO. Inside the API capture we have modules, which shows the calls from each of the DLL or the modules, and you can also look at the program threads, so it can show the information in different ways. And the way that is suggested to start to get a high level view is to find the actual executable within the modules, and you can follow the activity through here. So this early stuff's pretty straightforward. We can see which thread the activity is related to. We can see the API call and the return value and how long it took, etc. So first API call is get current directory. There's some memory stuff happening. And if we follow through, we can see that there's a open process call to run notepad.exe. Now, Notepad itself isn't inherently suspicious, but you know, spawning sub-processes from an executable is always suspicious. But if we keep following down, we can see that it's getting file attributes for net.exe and then initializing a process. And we can actually see the parameters that were passed to this executable. And basically what this is doing is enumerating the users or the domain admins group, which would include users and what permissions, etc. that group has. And that absolutely is suspicious for this to be happening within an executable and not as just a regular management task. If we keep following it down, we can see references here to CLR create instance. Following this, we've got OLE automation 32, and then we start seeing some strings being passed, which action execute VBS, Visual Basics. You see the domain controller, computer name, and then we can also see a URL being passed. Looks like just a web server, and downloading a executable to the temp directory on presumably DC01. So just to cover off on a couple of the things here, the CLR instance. CLR is the common language runtime function for loading .NET runtime into an application. Basically, it's a way of allowing non.NET applications to run .NET or VBA. The OleAut32.dll is objects linking and embedding automation, and that basically just allows objects created from one application to be embedded or linked into another. So together we could see that that would be injecting some sort of code into a running process, which in all likelihood would be Notepad. So we'll keep this high level. So having a look at Notepad, we can just select the executable and have a look at everything. There's quite a lot of information in there. If we look at Notepad itself, we can see that the executable itself didn't call any APIs, and that's likely because the code was injected from another process. And so I would imagine most of the information is on the CLR DLL, which it looks like it is. And there is a huge amount of information in here, which would take a very long time to walk through piece by piece. So I'll just have a look at what other DLLs have been called, see if there's anything that stands out. And just having a look through, the obvious one that stands out is Vault CLI. A quick Google will show that that's related to Microsoft Credential Manager. So if I look at So if we scroll down, we can see Credential Vault Client Library. So the activity on the Vault CLI looks like it started at 8:34, and most of the calls I would imagine would have come from CLR. So if we come over here and go down to roughly that time frame, and here we go. Load library, Vault CLI DLL, and then a process gets started for Vault enumerate vaults. And we can see a vault is opened and the items are enumerated. and an item is selected. So presumably they have accessed a vault, and we can only assume successfully exfiltrated some credentials. So if we go back just quickly, one of the points that I wanted to make, at the bottom here we see the computer name and then a URL is passed. If this is indeed used to download this executable, execute it from a temp directory on the domain controller, then there needs to be some way for that command to be sent from the employee's environment to the domain controller. And given this is a focus on open source tools, at a guess, I'd immediately be suspecting like PsExec or WMI, some sort of management interface that can be abused to send commands to other computers on the network. So to confirm that though, we can check out the domain controller event logs and look for WMI traffic or that download string, and confirm exactly how this command was sent across. So I'll jump back into the domain controller. I'll open up the event log. I think it's like high teens or somewhere in the 20s is the event ID for stuff to do with WMI. But the simple way would just be to search for that particular URL string, because that should be fairly unique. So if I copy this, and the first item that's discovered, it is 20, event ID 20, which is a WMI consumer event, and it's come from Alonzo Spire, and it's a script with a download URL saved as. So this confirms that WMI was indeed the protocol or interface by which the command was sent. Now to do that successfully, they would have needed the credentials for a domain administrator or for a user that had permissions on the domain controller. And so we can presume that those came from the vault. So I want to try something slightly different for this video, and that is to graphically lay out the timeline as we discover new things. Hopefully might make things a little clearer, because often we're discovering information at different points in the timeline. It could be hard to keep it all in our heads. So we can go through and add some actual timestamps later if we like, but just to at least start by showing the sequence of events. Basically what I think is at some point let's see, what's it called, csgo.exe Trojan downloaded and run on employee computer. csgo.exe injects .NET/VBA into notepad.exe, and it enumerates domain admins, and we also know that it accesses the secure vault. Accesses a secure vault, I should say, and then sends WMI, sends download command to DC over WMI. Then we have the domain controller downloads, looked like it was called FIFA24.exe, a game Trojanized, made to look like a video game, and saves, I think it executes and saves to temp. Okay, so one more thing before we start digging into what happens next. So we can see that there was initial access, enumeration, escalation. Before we move on, I do want to have a look at the network traffic and see whether we can actually catch when and where the CSGO executable was downloaded initially. So we'll go back to the employee and we'll open up the PCAP file. Okay, so there's a number of ways that we can slice this. It's quite a large amount of information captured. The simple way possibly would be to filter by that IP address that we saw previously, which is presumably the C2 server, where the domain controller downloaded the FIFA 24 from. But we can also, if we didn't know that, go into statistics, have a look at the conversations, and there's one conversation that stands out fairly significantly in terms of size, and again it's with the same server, 36165.8 and 10.10.079, so presumably that's the employee. This is what we presume is the C2 server. We see 18 megabytes has been transferred, so let's apply this conversation as a filter. Now when we go back, we can see the filter's been applied for us, and we can have a look at the traffic between these two hosts. If I follow this first stream, we've got a simple get on slash, which returns a simple HTTP server, and it's just got a directory listing. If I just exit that conversation, let's scroll this down. I need to set the filter again. So we have the get, favicon, there's a 404, and here we go, we've got the get on the csgo.exe. So if we follow that stream, we can see the number of packets being reassembled here. Very large number. And it does look like there's a executable that we can recover. So I'm going to set this to raw. I will save this as and call it csgo.exe, and we'll just need to do a quick edit to remove the headers. It should start from this MZ magic byte. So if we save that, let's just do a quick file check on it. We'll just do a file, CSGO. It's a portable executable. So before we go to the extent of reverse engineering it, let's just should just be able to grab the MD5 hash and head over to VirusTotal. So we should just be able to send the hash, and we can see it's detected on quite a number. Popular threat label, malgo/sliver. So Sliver is a open source C2 framework. There you go, Adversary Emulation Framework, built on Go, so it's cross-platform and quite popular with red teams. The next thing we can look at while we've got Wireshark open is what happens after the CSGO is downloaded. So reset this. So this is all the download, and then looks like once the download is complete, there's then traffic happening over TLS. So we can see there's a hello client hello from, so there's a reach back from the employee desktop 10.10.079 out to the C2 server, establishing a connection, and this is all going to be encrypted, so we're not going to get a whole lot of information about what commands are being sent, etc. So before we move on to look at the privilege escalation and what happened on the domain controller, let's see how many questions we can answer. So to which IP address and port number is the malware attempting to establish a connection? So it looks like, given this is a TLS session, it's probably going to be the C2 server, 165.8, and that's over 443. It's then asking about, now we're aware of the IP address and port number, what is the JA3 fingerprint? JA3 fingerprint is a way to track bots or malicious clients, even as their addresses, IP addresses and certificates change. So it takes a whole bunch of information about how the client negotiates its certificates, and then it puts all of that information, concatenates it together, does an MD5 some of those, and uses that as sort of a signature to try and track malicious actors as they change IP addresses and change certificates, etc. We can actually grab that straight out of Wireshark. So if we look into the transport layer, security, we can look at the handshake protocol, and it automatically calculates the JA4 and JA3 strings, and so it's this 1.9 string that we need to copy. So we copy the value of that. And that's the answer there. Task 3, what is the name of the C2 framework being utilized by the red team? We're fairly confident at this point it's Sliver. There's a question about which Win32 API provided the red team with the current directory information. Now we saw that in the start of the CSGO. I'm sure it's used several times throughout, but it's the get current directory W. We can also answer task 5. So now that we've identified the C2 framework, Sliver, which command is responsible for opening notepad.exe by default and loading the .NET CLR into it? So if you're not familiar with Sliver, you can just Google this one. So you can just Google something like Sliver C2 inject.net. Whoops. And we can see there's a whole tutorial here which is about the execute assembly command, and you can have a read through how the implant works, and there's a whole lot of information about exactly how that works. Okay, we can answer task 6 as well. What's the name of the module DLL that was loaded to gain access to the Windows Vault? And that was Vault CLI.dll. Okay, task 7, after loading the mentioned module, which specific API was responsible for enumerating vaults? So we can have a look that Vault CLI/DLL, first called at 8:34 and 8:66. This is where the library gets loaded, and then we see vault enumerate vaults is the API call. So if I just copy that, I just have to clear the junk, so paste that, and the answer is vault enumerate vaults. Task 8, after loading the mentioned module, there are a series of calls. Which specific one is responsible for enumerating the vaults? Double paste. Question 8 is actually meant to be, which command did the attacker execute to identify domain admins? So we saw that in CSGO. We can see .NET, and the specific command is netgroup domain admins /dom. Once again, we will copy the API column, and we just need this part. Okay, tasks 9 through 11, we need to have a look at the domain controller. Once again, we can start by having a look at the APIs. So if I open DC capture, and we have 5, we've got FIFA 24, which we know is downloaded from the C2 server, and then 2 instances of command and 2 instances of PowerShell. Again, we can have a look at the FIFA 24 and follow what was done. We see that cmd.exe, it creates a process, and we can see it's then running ntds util, and this is a command basically to back up the ntds. The ntds is the NT directory service, and the ntds.dit is basically a complete dump of all of the domain controller, including all of the sensitive information like NTLM hashes, and it's effectively the keys to the castle. And it looks like it's creating a full snapshot into the temp directory and calling it this oddstring.dat. Looking through, it then goes to that directory, sets that as current directory, runs PowerShell, and zips the ntds.dit up into a ntds.zip, so it compresses it. So if we have a look at what the remaining questions are, actually let's update our timeline. And so we can say after it executes FIFA24.exe, the next activity in the timeline is that a backup of the DC ntds.dit is made and then compressed. So let's have a look at what the final questions are. The red team has provided a hint that they utilized one of the tools from Armory for lateral movement to DC01. What's the name of the tool? So lateral movement to DC01 we know took place using a WMI command. And if we have a look at Sliver, GitHub, We can have a look at the wiki. Go to the docs, go to Armory. And we can see the list of tools here. So basically what we're looking for is the WMI tool. You could, for example, use Impacket, would be another open source script to run WMI commands, but we can see that they use the Sharp toolkit in Sliver, and Sharp WMI is the tool that was used. So that's Sharp WMI, which command was executed by the reg team to extract and dump the contents of NTDS. And we just saw that. If we go back up, here it is. And we can copy the API column once again. And we just need this part here between the quotation marks. That's the command. And finally, the red team has obtained the aforementioned dump by compressing it into a zip. Which specific Windows API is responsible for retrieving the full path of the file to be downloaded? So this is going to be towards the end of the activity here, and we're looking for the, I think it was named ntds.zip. It's further down than that. That's where they're zipping it. That's being compressed, and here we go. Get full path name, W. So this is the answer for question 11. So that's pretty much it. Obviously you could also grab the Wireshark and download the FIFA 2024 executable as well. It shows up similarly on VirusTotal, and if you actually copy the file itself across, you can get information about what IP addresses were reached out to, and what the actual behavior of the executable is as well.